The topic we're going to discuss today is kinematics. It's like one of the most fundamental chapters you can have, and although these equation of motions are not directly included in the syllabus, I think they're really important for the O level. So anyway, if we look at this velocity versus time graphs, as you know, you have all seen velocity versus time graph. Over here we have an object which is starting at an initial velocity u, so I define u as the initial velocity. It starts with the initial velocity u, and let me write down as initial velocity, and then you have v, which is the final velocity. And between u and v, it takes time t to go from u to v. Now between u to v, during this time t, we assume that this object is accelerating at a constant acceleration a. Now we'll try to find out if this first equation of motion, which I've written down over here, does it make sense at all or not. So what does this equation tell us? V is equal to u plus at. Now if I try to rearrange this equation, if I say v minus u is equal to at, we know that acceleration is the rate of change of velocity. So v minus u is actually the change of velocity. If I divide it by t, that is the rate of change of velocity is equal to acceleration. So more or less this part makes sense. Now if we go to the second part, what if I want to find out the displacement done by this object during this time t when it's accelerating from velocity u to velocity v. Now if we look at this graph over here, right, we know that from velocity time graphs, if we take the area under the curve, which is basically this whole area, this gives us the displacement. Now when we are doing this area under curve thing, since we are not familiar with calculus and integration, we try to look for familiar geometric shapes. So in this case what we have is a triangle. As you can see, if you look at my mouse pointer, you can see it's a triangle over here and a rectangle, okay, and this total thing, which is the triangle plus the rectangle, makes the displacement, total displacement. So if I call the total displacement d, you have the first triangle. Now what is the first triangle? Okay, one side, this side of the triangle, it's v minus u, and always this side is t. So the base of the triangle is t, while the height of the triangle is v minus u. You know that the area of the triangle is given by half base into height, so we call it half. Now the base was t and the height was v minus u. Now on top of the triangle we also have this rectangle. Now the rectangle, the side of the rectangle is, since the origin is 0, one side of the rectangle is u while the other side is t, and as you know, the area of a rectangle is simply length into breadth or length into height, so we can just write it as u times t. Now if we work this out, this is like half t. Now we know that half this v minus u can be expressed as a times t, as we can see up. So to make this thing more simplified, rather than keeping it as v minus u, since we know the acceleration, we can simply write v minus u, we can replace it with a t. So I replace that with a times t, then you have plus ut. So this works out to be displacement is equal to ut, this term over here, plus half a t square. If you read furthermore, you discover that this is one of the very important equations of motion. So this is what, then there's this other equation of motion, which is v square equal to u square plus twice as. I think it's better if I use a different color for this. So this is the third equation of motion, and we are going to try to derive this as well. So we know that v equal to u plus at. So v square is equal to u plus at whole square. And I'm assuming most of you know that a plus b whole square equal to a square plus 2ab plus b square. So if I write this out, v square equal to u square plus twice a t times u, because of this u square plus twice a t plus a square t square. Now the beauty of this is, if you compare this equation with this equation over here, you can see that we already have the first term, so we have to get the second term. So what you have to do is u square, and then you see it's taken 2a. So if you take 2a common out of this, what you get is ut plus voila, half at square. Now we know, by the way, there's a s over here should be d, which is the displacement. Okay, that's the correction. So we know that d is equal to ut plus half ad square. So if we look at it, you see u square plus twice ad. This is, so in summary, if we write down the three equations of motion, first one is v is equal to u plus at. This is important. Second equation is displacement is equal to ut plus half ad square. Sometimes I write the displacement as s and d are the same thing.